Welcome back. In this video, we will learn how to delete a node from a linked list at a given position. Let us consider this linked list, and this linked list has 4 nodes. And we will check one variable that is a user pose, where the user will provide the position of the node to be deleted. Suppose the user wants the first node to be deleted. We take this temp_pose variable and initialize it with 1. The role of the temp_pose variable will be to keep track of the temp's position in this linked list. Now, we already know that the temp pointer is used to traverse over the list. So, we write here, if user pose is 1, then start will be start next. Why? Because if this first node has been deleted, then the node at 478, which is a second node now, will be the first node, right? So, start should point at the second node at 478, which will be the first node after deletion of this node at 743, right? So, start next will be 478. You see here that 478 is a start's next one. So, it will be loaded with 478 now, and start will point to the node at 478. Got it? Next, you write free temp. That means the memory here that is pointed by the temp pointer will be deallocated now. And you see that the temp pointer still points to the location at 743. So, temp should be pointing to null now. So, it becomes null and it will be looking like this. So, you see that the first node from the list has been deleted and the start is now pointing to the node at 478, which was previously the second node, but after deletion, this node at 478 is a first node now. You write break here because your job is over. Now, let's get back to the previous situation. The start is pointing to the 743 and temp is also pointing to the 743 now. And you see that the user pose is 3 now. That means user wants the node at third position to be deleted. That means this one. So, it will be in the else for. You write save equal to temp. You already know from the previous videos that we use a save pointer which follows the temp pointer, right? So, wherever the temp moves, the save always follows one node behind the temp pointer, right? So, here also we will do the same job. First, we start the save pointer pointing at the same node at 743, just like temp, right? So, it will point to the node at 743. Next, you write temp equal to temp next. Now, what is temp next? Temp next is 478. That means this node. So temp should be updated with the value 478 here in place of 743 so that it can point to the node at 478. So temp next is 478 now. So 743 is updated with 478 and temp starts pointing to the node at 478. So you see the situation that temp is pointing to 478 and save is pointing to 743, just one node behind the temp pointer, right? Next, you update a position because you have moved the temp pointer from the first position to the second position. So temp pose is now 2. It started with 1, just remember that. So when you write temp pose equal to temp pose plus 1, so temp pose is now 2. Now you check whether temp pose is matching with user pose. You see that the user pose is 3 now. That means the user wants to delete the node at 521, right? But temp is actually pointing to one node behind the required node to be deleted, right? So this is not matching. So if condition will not fire now. So what it will do, it will go back to run the while loop because temp is still not equal to null and user pose is not 1. So it will fire the else part again and it will execute this line, that is save equal to temp. So once again it will go like this, that temp is 478 now. It will be stored in save. So save is 478 now and save will start pointing to the node at position number 2. The next line you see that temp equal to temp next, the same thing. So temp next is 521. So this will be stored inside temp so that temp will start pointing to the node at 521. Now the third line, temp pose equal to temp pose plus 1. The temp pose will be updated to 3. Now what do you see? You see that the user pose is 3 here and the temp pose is 3 here. That means it matches, right? So you write save next equal to temp next. Why? Because if you want this node to be deleted, then this node must be linked directly to this node, right? So the second node will be linked to the fourth node. That means the save next pointer here will be loaded with the address of the fourth node. Now the address of the fourth node is 291. Now where will you get this 291? You see, the 291 is there with the temp's next pointer, right? That is why you load this temp next address, that is 291, inside save next. Got it? So this has been updated to 291. Now as soon as this is 291, then this link breaks and this link is established. So you see that there is a direct link from the second node to the fourth node. Now, you write free temp. That means you have to deallocate the memory at 521. So you write free temp and it will go like this. Next, you see that temp is still pointing to the 521 address, which is actually deallocated. So temp is now a dangling pointer. So to avoid this, you write temp equal to null. So when you write temp equal to null, it becomes like this. Next, you write break because your job is over. So let's clean up a little bit. This becomes 3 and it will be looking like this finally. So I hope it's clear to you that how to delete a node at a given position in a linked list. Now, one thing I should mention you that till now, whatever we have done with linked list, this type of linked list is called singly linked list. Okay, singly linked list, right? Because there's a single pointer, the next pointer to each node. In the next video, I will give you an introduction to doubly linked list, where each node will have 2 pointers on each side. Thank you for watching and take care.